Alrighty, in this section we're going to keep with our idea of permutations and combinations and that fundamental counting, and we're going to apply it to honestly just more complex problems. My first problems on this page are going to use cards as their example. So I have the picture of the cards there that we've already used just to remind everybody how many face cards, how many of each suit. So just real quick, there are 12 face cards. And there are 13 of each suit. There are 26 red and 26 black cards for a total of 52 cards. Just kind of a quick rundown of those same card facts that we looked at in exam 2. All right, for these first problems, there are going to be two different ways to work them, so I'll show both ways. We want to find the probability of drawing 2 kings. When I start with, there are 4 kings. So the first card, the probability would be 4 out of 52. Once I already have a king taken out, there aren't 52 cards anymore. There are only 51 cards. And there aren't 4 kings because I already drew one of them out, so there are only 3 kings. So I could work with the problem that way. And I want to get my answer all the way reduced down. My answer is going to be the most reduced form. So that would be 1 over 221. And your calculator will reduce fractions. Depending on what model you have, it could be different steps. But that's something you can always email me if you want the steps to. Or you can go on YouTube and just type in the name of your calculator, TI-83 reducing fractions, or TI-36X Pro reducing fractions. There are lots of videos up. Or just email me for directions as well. All right, another way to work it, I'll do it in a different color, is to use combinations. Now the total is going to be on the bottom, and notice our total is 52 cards, and I am choosing 2 cards. And the kings are going to be on top. There are 4 kings, and I'm picking 2 of them. Either way, you can type either one of these in. Your reduced answer is going to be 1 over 221. All right, let's look at B here. Again, there are going to be 2 ways. So the probability of drawing 2 face cards, like I said above, there are 12 face cards. So the probability of that first one is 12 out of 52. Once I take one of those face cards away, I'm only left with 11 of them. So 11 out of 51. Or we can use our combinations. My denominator is going to be the same, that total. And on the top, I'm going to use face cards. So I would have 12 combination 2. Either way you want to type that answer in, the reduced form is going to be 11 over 221. All right, so I want you guys to maybe try 2A here. B is a little bit different, so you don't have to try that one. But give 2A a shot. It's going to work very similar, except for we're dealing 4 cards. So you either need to have 4 fractions. I had 2 fractions set up here. So instead of 2, you would have 4. Or instead of choosing 2 cards, you're going to choose 4 cards. So give it a pause and try 2A. All right, coming back. One way to work it with the fractions there are 13 hearts, and we're going to keep reducing down each time we draw a card. We only pick out 1 card at a time, so we reduce it 1 at a time, just decreasing by 1. This one did say to round to 6 decimal places, so I can leave it as a decimal. That's going to give me 0.002641. Or, to get the same answer, we could use our combinations, and we would have a 13 for the number of hearts there are, and we're choosing 4, over 52 choosing 4. Both of those are going to get us our same answer. Now B is slightly different. That's why I said we didn't have to work it, because it says in that order. So in that order means instead of using combinations, I'm going to be using a permutation. Remember, a permutation is when order matters. The other cards, the order did not matter. This one it does because it said in that order. So I want to draw 2 queens first. So the fraction style, there are 4 queens out of 52 cards. Then I'm going to draw another queen. They would give me 3 out of 51. So these are the queens. Then I have to do the kings. I'm going to start back over because there are now 4 kings. I started drawing queens, now I'm drawing kings. So there are 4 kings, but there are only 50 cards because I drew out 2. And maybe it would help with visuals if I come up here to the top. For my first card, I drew out a queen. So let's say I drew out that one. Then I drew out another queen. Then I'm going to pop over for my next fraction. I'm going to pop over to the kings. There are still 4 kings left, but there are 2 less cards. So my denominator is still decreasing, even though my numerator kind of changed patterns. I'm supposed to pick 2 kings. So after I pick 1 king, there are only 3 left. So I can type in that fraction, or I could use permutations. Now, I should label this. I'm going to have a permutation for both the kings and the queens. So there are 4 queens and I'm choosing 2. We're going to multiply that. There are 4 kings and I'm choosing 2. All over the total, 52, and I'm choosing 4 this time. Just going to point out a couple things. Notice the number that I'm choosing. If I add those together in the numerator, it should give me the denominator number that I'm choosing. And then just to label this, I've got a permutation for the queen, a permutation for the king, and a permutation for the total here. And whichever one you type in, we're supposed to round to 6 decimal places. So 0.0000022. And remember, some calculators might give us that scientific notation that we talked about before. So if you see something with the E, that stands for exponent, and that means you need to move the decimal over. So you might have gotten scientific notation on this one, so we would have had to move the decimal over to standard form for our final answer.